Hi everyone, let's work through a couple of must-know questions involving direct and inverse proportionality. Now the first question we work through is the one we have here, and it involves direct proportionality. We're told that y is directly proportional to x. We're also told that when x equals to 4, y is equal to 20, and we're given three questions, A, B, and C. Now, in a test or an exam room, when reading this question, the first thing you have to pick up is the fact that we're told that y is directly proportional to x. The fact that we're told this allows us to state, without even thinking, that y is equal to some number k times x, where k is known as the constant of proportionality. Now let me insist, you can go ahead and write this without even reading the rest of the question, thanks to the statement y is directly proportional to x. Alright, now that that's out of the way, let's go ahead and work through these three questions. The first question, question A, we're asked to find the formula for y in terms of x. Well, we already know that y has to equal to k times x. So when we're asked to find the formula, all we're really being asked to do is to find the value of the constant of proportionality, k. And to do that, we use the information that we're given in the question. That is, when x equals to 4, y is equal to 20. So let's go ahead. So I'll just write question A. Starting from the fact that we know that y is equal to k times x, we can replace x by 4 and y by 20 to obtain an equation for k. Here's what I mean. I replace y by 20 and x by 4. That leads to 20 equals to k times 4, which we can quickly rewrite as 20 equals to 4k. Now, since we have 4k on the right-hand side, I'm going to divide both sides of this equation by 4. And that leads us to 20 over 4 equals to k. And since 20 divided by 4 is equal to 5, that leads to 5 is equal to k, or simply k is equal to 5. And we now know the value of the constant of proportionality. And using that, we can now state that y is equal to 5x. And that's the formula for y in terms of x. Now that that's done, we move on to the second question, question B. Now in question B, we're asked to find y when x equals to 12. Well, for that, we use the formula we just found. Indeed, starting from y equals to 5x, if we replace x by 12, then that becomes y equals to 5 times 12. And calculating that, y is equal to 60. Done. When x equals to 12, y equals to 60. We move on to the third question, question C, in which we need to find x when y is equal to 135. Well, again, we start from our formula, so that was y equals to 5x. And this time, since we're told that y is equal to 135, we replace y by 135 and solve for x. That is, we write 135 equals to 5x. Now on the right-hand side of the equation, x is being multiplied by 5, so to get rid of that 5, we divide by 5, and we do that on both sides of the equation. That leads to 135 over 5 equals to x, and by all means check, but 135 divided by 5 is 27. So we obtain 27 equals to x, or simply x equals to 27. And we're done. We've just answered all three of these questions involving direct proportionality. Now, before moving on to inverse proportionality, do make a note of the fact that as soon as we're told that y is directly proportional to x, it allows us to state, without even thinking, that y must be equal to some number k times x. Alright, that being said, let's look at inverse proportionality. In this case, we're told that y is inversely proportional to x. And we're told that when x equals to 12, y is equal to 7, and we're then given three questions to answer. Now, the first reflex to have is to realize that we're told that y is inversely proportional to x. And without even thinking, that allows us to state that there has to be some number k such that y is equal to k over x. And once again, k is known as the constant of proportionality. Keeping in mind that this result is what y is inversely proportional to x actually means, we move on to the questions. The first question, question A, we're asked to find the formula for y in terms of x. Well, since we know the result that I just boxed here, all that really means is we need to find the constant of proportionality, k. And for that, we use the information that we're given in the question. That is, when x equals to 12, y is equal to 7. So in a similar way to what we saw in our first example, all we have to do here is replace x by 12 and y by 7 and calculate for k. So let's go ahead. We can go ahead and state that 7 is equal to k over 12. Now, on the right-hand side, k is being divided by 12, so to get rid of it, we multiply both sides of this equation by 12. And that becomes 7 times 12 is equal to k. Finally, since 7 times 12 is 84, we can go ahead and state that k is equal to 84. And we now have the constant of proportionality. And we can therefore state the formula. Y is equal to 84 over x. And that's the first question done. We move on to the second question, question B, in which we're asked to find y when x is equal to 21. Well, using the formula we just found in question A, we know that y is equal to 84 over x. So to find y when x equals to 21, all we have to do is replace x by 21 and calculate. So that would be y is equal to 84 over 21. And since 84 divided by 21 is 4, that leads us to y equals to 4. And that's the answer. Finally, we move on to question C, in which we're asked to find x when y is equal to 5. And once more, we start with our formula. We have y, which equals to 84 over x. Now, to find the value of x when y is equal to 5, we're going to replace y by 5 and solve for x. So that would be 5 is equal to 84 over x. But we see here that x is on the denominator. So to get it away from there, we're going to multiply both sides of this equation by x. And that leads to 5x equals to 84. Finally, dividing both sides of this equation by 5, we can state that x is equal to 84 over 5. And by all means check, but 84 divided by 5 is 16.8. And that's the final answer. And so that's how we can solve those typical exam-style questions involving direct and inverse proportionality. And that's it for this tutorial.